Assalamu alaikum students. That is lecture 8 of plasma physics. Here we discuss the fluid drifts. Basically, this chapter is about fluids, and we know that when we have fluids, we have all the charges. That is, we have ions, we have electrons, and we have neutral particles. So a fluid element contains many individual particles, and it is expected that fluid element will exhibit drifts similar to the drift of individual particles. It means that individual particles, when one individual particle has drift, then similarly all the individual particles in the fluid also have drifts. So, however, in a fluid plasma, there is an additional drift associated with the pressure gradient that is not found in the single particle picture. Pressure gradient, how the pressure gradient is produced? Pressure gradient is produced when we have number of particles, then they exert forces on each other. So, due to this, we have another drift, that is for because of the pressure gradient. To see how this happens, we can consider the fluid equation of motion for each species. We have Mn is equal to Mn. This relation, we see this relation in the case when we have connective derivative. In the case we discuss in the first topic, first lecture of this chapter, that is when we have the connective derivative, and that from here we can write that Mn is equal to partial u over partial t plus u dot del into u is equal to Qn E plus u cross b minus delta p. Now what is this u? U is the average velocity. You know that the average velocity u of the particles in the fluid. When we say that we have a fluid, then that velocity is first we have velocity v, and when we have a fluid, the velocity is u. And we write here E plus u cross p, and that minus delta p is due to the pressure. In this case, for drifts, if we say that due to the magnetic field we have cyclotron frequency. So, but here if we say in the fluids, the drifts are slow compared to cyclotron frequency. So at that time we may neglect this. We may neglect the term Mn partial u by partial t. That is the drift velocity, that is due to the drift. So compared to the term Qn is equal to u cross p, that is due to the cyclotron frequency, and that is the drift velocity. So neglecting the connective term, again this connective term is also neglected because this term is responsible for drift of the charged particles, and this term is responsible for the cyclotron frequency. So and then taking the cross product, we neglect both of these equations, both of the equation on the left hand side, and then taking the cross product of this equation with b, we get Qn E cross b plus u cross b minus delta p cross b. Now basically we neglect the left hand side equation because there the drift is very small than the cyclotron frequency. So now we can this u cross b is equal to, we can write it as minus b cross u cross b, that is also equal to the vector triple product, that is a cross b cross c, that is back cab rule. So we know that the back cab rule is equal to u b square plus b b dot u. That is equal to, and from here we can say that the velocity, average velocity, is also parallel to b and perpendicular to b. And we know that when we have the perpendicular component of average velocity, then b dot perpendicular is equal to 0. But if we have the parallel component of average velocity, then there is b parallel to u parallel. So it means when we have the parallel component of average velocity, then this value exists. So minus u parallel plus u perpendicular b square plus u parallel b square. We can write it as u parallel b square, because both are parallel to each other. So we say that we can write it as bu perpendicular, bu parallel, because b dot u is equal to, in this case is equal to 1. In this case is equal to bu parallel cos 0. Cos 0 is equal to 1. So from here minus u perpendicular b square, this term u parallel b square plus u parallel b square is equal to 0. So therefore from equation 4.62, this is the equation 4.62, we can write here basically this u parallel, this minus u cross b is equal to minus u perpendicular b square. If we put the value here, minus u perpendicular b square, from here minus u perpendicular b square, then we can take it here outside, that is equal to u perpendicular b square qn u perpendicular b square. Clear? When we have this u perpendicular b square here, that is also minus, because u cross b is equal to minus u perpendicular b square. When we have this is minus u perpendicular b square, take it outside, and on the left hand side we have qn u perpendicular b square. Clear, students? Next we can find the value of u perpendicular. U perpendicular is equal to E cross B over B square, because Qn is cancelled, minus delta P cross B over Qn B square. Clear? Now this is equal to UE. You know that when we discuss the single particle cases, then at that time we have this value, that is E cross B over B square, that is the velocity of the guiding center, VE. So here we can write UE, and that delta P cross B over QNB square is so called diamagnetic drift, a fluid effect. That is due to the fluid effect when the plasma is taken as fluids. Note that UD depends on the sign of charge. Basically it depends on the sign of charge, because we have Q. So electrons and ions will drift in opposite direction, so gives rise to a diamagnetic current. We know that JD is equal to NE UDI minus UDE, and from here this is equal to this, and we can write wait a minute, and we can write this equation JD is equal to NE UDE minus UDI minus UDE. Now here UDI is equal to QP cross P over QNB square. Delta P. अब delta P is P, you know that P is equal to pressure and P is equal to NKT. So from here we can write if you neglect this minus or change this minus into plus, we can write B cross delta P. Clear? Now this P is equal to NKT. Clear? So from here we can write B cross delta N. KT is constant, we take it outside. Clear? NKT, and from here we can say this in this N is cancelled, and where is Q? N is cancelled, and we have KB TI plus KB TE B cross delta N over B square. So from here the physical origin of the diamagnetic drift can be understood from equation 4.5, which shows the orbits of plasma ions gyrating in a magnetic field for a pressure or density gradient towards left. There are more ions moving downward than upward, since the downward moving ions come from a region of higher density. Thus, a fluid drift occurs perpendicular to delta N and B. As the guiding centers are stationary, this drift does not occur in single particle theory. It means that the delta N is towards left, so the drift is greater on the left hand side than the right hand side. The curvature drift of single particle picture also exists in fluid picture, because all the particles in a fluid element feel centrifugal force as they move around curved magnetic field. However, the gradient V drift of single particle picture does not exist in fluid picture. This is so because magnetic field cannot change energy and distribution of plasma particles. The particle drifts in any fixed fluid element cancel out. We ignore as much the theory, so write only this theory, and this diagram is important. Clear, students?